All right, so today we're covering a very hotly requested topic, how to test Akka.NET applications. So this is going to touch on a number of things. Probably the thing we're going to spend most of our time on is actually how to make Akka.NET applications testable. So how do we do things like separate state and behavior, and how do we create deterministic outcomes? That's like a $5 word for basically saying, how do we make test behavior predictable? Given that actors run asynchronously and typically on background threads, how do we go ahead and try to make it easy to make sure our tests aren't racy? We're going to talk a bit about using the Akka.NET Test Kit. Now, we're not going to explore every single piece of functionality the test kit has because there's quite a number of different things that it can do, but I'm going to show you the 20% of it that I use 80% of the time. And it's fairly easy to kind of discover what the test kit does using autocomplete. So it's one of those very discoverable sort of APIs that's available there. We'll talk a little bit about working with dependency injection. So this is Akka.DependencyInjection and Akka hosting. What are some things you might want to keep in mind about using that inside your tests? And then we're going to kind of wrap up with my favorite piece of functionality that we've introduced over the past couple of years, which is the Akka.Hosting.TestKit for integration testing. I actually use the Akka.Hosting.TestKit in some parts of our applications that don't even use Akka.NET because it makes it possible for me to wire up an entire service collection without mocking it. So it's actually using real dependency injection under the covers. And it provides me a lot of reusable infrastructure that kind of makes it convenient to test things like, let's say, other background services or maybe even ASP.NET controllers, all that sort of stuff can kind of tidy in right in with it. So our code sample for today is available on my personal GitHub. It should be pretty close to the top of my most recent repos on there. It's the same repo we used for our application management best practices webinar about a year ago. I've added a whole bunch of unit test examples to that over the past day or so, and we'll include links to this in all the automated emails that attendees and people who are just receiving the recording will get maybe about an hour or so after the webinar finishes. So this is the primary code sample we'll be looking at today. Now let's kind of talk a bit about the first part, which is how do we make Akka.NET actors more testable? How can we kind of design our Akka.NET applications for maximum testability? Well, a couple of things to bear in mind. The easiest way to do this is to actually try to extract your state and your behavior from Akka.NET actors themselves. This is also what developers recommend for working with ASP.NET, for instance. It allows you to basically kind of take your state models, take maybe some of your domain logic, and test them as like standalone services that aren't integrated directly with Akka.NET's own infrastructure. That will help simplify your test design. That'll help reduce test execution times. You're not waiting for background async work to complete. And it's also, yes, the same best practice that ASP.NET Core and others recommend as well. It's the whole idea of having skinny controllers in ASP.NET Core. Now, really important caveat I need to throw out right away. It's not always feasible to do this. The reason being is that some of your behavior that your domain has might be super dependent on Akka.NET specific concepts. Behavior switching inside an actor for modeling a state machine, for instance, is a really common example of this. Or another common example might be tying into some other piece of Akka.NET infrastructure like Akka.Persistence or maybe distributed pub/sub. Don't create a bunch of really complicated infrastructure for the sake of making things more testable. You're just going to end up with a code base that's bigger and has more things that need testing in order to do it. I'd probably opt to just do an integration test at that point rather than try to extract a whole bunch of infrastructure out of my domain stuff in order to make that possible. So the caveat I'll say here is just do the best you can. If it's easy to extract your state out of it, do it. If it's really painful to extract a piece of behavior out of your actors because it basically leverages Akka.NET specifically, then don't do that. Just go ahead and write an integration test and it'll be fine. That's all you need to do there. So you don't need to have a one-size-fits-all model for how you do testing. But this is what I think generally produces the best results. Let's take a look at a clear example of this. Now, it's no accident that I'm reusing our code from our Akka.NET App Management Best Practices webinar, because this implementation was designed to be very testable on the onset. All we're talking about now is how to actually do the testing. So this is our subscription state actor. It manages a subscription. So for a specific user, for a specific product over a specific duration and price. And so for every subscription this user has to any given product, there will be a distinct subscription actor for that. So we have our subscription state. And then we have some of our behaviors this actor is going to use down here. Recovers, this is how we replay data from Akka.Persistence. Commands, this is how we create side effects and change our state. Commands had to be validated and all that jazz. And then down here, we also have queries, which is, if someone wants to fetch data from this actor while it's running live, a query message is going to be how we implement that. So this is kind of a really basic actor, and we've already have somewhat encapsulated the state inside its own little record type right here. We also have some external services we're going to inject into this actor. For the purposes of this case, we're simulating a connection to a payment service. So this payment service could be Stripe, could be something much more simplistic that maybe sends purchase orders via QuickBooks Online. Whatever the case may be, it's not super important how this works. We're just injecting it into this actor, and I'm making it a point of clarification here. This is literally what people have been doing for years with ASP.NET Core. I wanted to just go ahead and illustrate that this is something that we're also going to be doing with Akka.NET actors. DI capabilities in Akka.NET have improved quite a bit over the past 3 years or so. So we're going to be DIing this stuff just like you would in any vanilla ASP.NET Core application. So it's kind of meant to be familiar in that respect. Now this is the only command handler this subscription state actor has implemented. We have some domain specific behavior, but it's all encapsulated into these extension methods that key off of our subscription state. All the domain specific behavior gets encapsulated there. And we also take that payment service that gets injected into the actor, and we pass that in as a parameter into our process command async method right here. These are ideally, the way I try to model these command processing extension methods should ideally be pure functions. That's going to go ahead and make it easier for us to reason about effects that are getting reproduced, makes it easier to reason about things like retries, all the sorts of real world concerns that come up when you're building, an asynchronous piece of software that runs in a real business context. And then down here, we also have the apply function. That's how we modify our state. It's basically doing a mutable update to this record that we have here. And don't worry, we're actually going to see the record type in question, and we're actually going to see the methods that we use to test it in just a second. Over here in yellow, these are all the Akka.NET infrastructure calls themselves. So one kind of distinction I'm making from a testability standpoint is what belongs to my domain versus what's Akka.NET infrastructure that kind of helps me deliver it, right? So in this case, I'm checking to see, okay, if we tried to produce this command, and if we have tried to process this command, and if for whatever reason that command didn't produce any events, we can kind of do an early return right here and just tell the sender that, here's what the result was that we processed. If we did produce some events, we're going to go ahead and persist those. That's how we make this actor state durable and reentrant. So we're going to go ahead and persist those down here. And after we're done persisting all these events, we'll go ahead and check to see if it's time for us to save a snapshot, which is just an optimization for Akka.Persistence. So if you have an actor that's persisted a large number of events, you don't want to necessarily replay all of them every time this actor starts. Snapshots are a way of being able to kind of short circuit the recovery process. That's all that we're doing here. So this is Akka.NET infrastructure. The stuff we ideally want to test is the domain specific behavior. The Akka.NET infrastructure calls we might also want to test as well in order to make sure we've done things like made sure that all of our persistent events are serializable. That might be an example of a piece of infrastructure you might want to test that's specific to your application. But otherwise, generally speaking, we're going to kind of draw a distinction between these two things. And I'm actually going to have separate tests for each of these in this specific example. So this is how we're going to test our domain behavior here. In fact, you know what? At this point, I might actually go and bring up Rider. Let me grab Rider. All right, got all this here. And let me get rid of my breakpoint. This is my subscription state object. It's basically just a data type that has no business logic itself. It's just meant to kind of describe the state of a subscription at any given time. So we intentionally make it simple. We also intentionally make it immutable by declaring it as a record type. That way we can freely share this state with other actors, or we can actually share it during testing. That's going to become important later. This allows us to go ahead and do all of that really simply and safely by making it immutable. So that's something that we typically encourage developers to do when they're working with Akka.NET using modern C#. F# developers, you guys always got this for free, but C# developers, we have to kind of do a little bit of extra ceremony, which is make it a record type, make all these properties in it only. And then if we have things like collections, maybe make sure those are read only or immutable, as the case may be. So this is our subscription state. And then down here, we have some extension methods where we're going to process commands, and based off the command type, we might have some domain specific processing that we're going to run, such as when we create a subscription, I am going to create a subscription created event. I am going to attempt to create a payment using our payment service. If that payment was successful, we will go ahead and include this subscription created event, and we'll also go ahead and include this payment amount processed event on here as well. In the event that we fail to record a payment, we're going to go ahead and still create the subscription, but the subscription is going to start in a payment overdue state because the initial payment attempt failed. So this will go ahead and change the way the actor behaves on subsequent attempts to do something with the subscription a little bit later down the road. So that's basically what we have here from like a domain logic standpoint, not super complicated. Well, to test this code, here's what's really interesting. This is, and I'll go ahead and bring this out here. Actually, I'll hide that for now. But this is a basic xUnit test fixture. And in fact, I actually have a nested test fixture under it that does not use any Akka.NET infrastructure whatsoever. It's simply testing our record types, plus like I made a fake for the payment service that allows me to basically indicate whether or not this payment should fail or it should succeed. That's all that's doing right there. And what we're going to do is we're going to start with this initial subscription state. We're going to assert that the initial state should be in a status of not started. This has some implications for how our actor is going to respond to queries. And then down here, I'm going to say, okay, we should be able to process a creation event for the same subscription ID. So we're going to make sure that the create subscription command corresponds to the subscription ID that we initialize the state with. And as long as that's true, we should be able to, basically essentially process this event successfully. Process this command successfully. We should produce two events in response. The first should be subscription created. The second event should be a payment processed event. Interestingly, I was able to find an error when I was writing this yesterday in our original webinar code from last year. Because we were not using value types, we were using primitives everywhere, strings, basically. I was actually passing the payment ID into the subscription ID right here. So the payment's subscription ID was wrong. And our test caught this. That's really nice that I'm able to find, let's say pretty basic errors like that without having to spin up an entire actor system and create actors and message them in order to do it. I can do all of that in a really simple, easy to follow unit test that requires no infrastructure. That's one of the reasons why we want to try to extract all this stuff out of the actor if it is possible. And like I mentioned earlier, don't fight the framework if it's not possible. If you're leveraging Akka.NET really closely and some of your behavior is highly coupled to Akka.NET specific mechanisms, don't write an entire abstraction to extricate Akka from that just to make it testable. You're probably actually making your code more complicated unnecessarily if you end up doing that. We'll talk about using Akka.Hosting to integration test later. That's the better strategy for solving that type of problem. But otherwise, here we can go ahead and see this is what a really basic test using our state behavior, or using our state object by itself. This is what I would prefer to do for the majority of our production code. And we'll actually see some unit tests from a real product that we're trying to deliver here at Petabridge by the end of the year. And it looks quite a bit like this. And yeah, here's the actual error that we had before. We also, by the way, went back and added value types yesterday to try to make these problems more discoverable at compile time rather than require a unit test to do it. So we introduced the subscription ID type, and now it's really obvious that we're passing the wrong thing into here. And if I made the payment ID also a value type, then this would definitely not compile. And we would know that, oh, we've introduced a programming error, or we've uncovered a programming error that was there previously. That's a whole subject for a different day, but nevertheless, this is a real bug that we found writing these tests. Now, that's the first bit. Try to separate behavior and state from your actors so you can test your domain logic independently from your Akka.NET infrastructure. The next bit of, let's say, design aesthetics that are go into making actors testable is making sure you have a way of testing the Akka.NET infrastructure with a deterministic outcome. Now, here's the problem that we're trying to avoid. Actors are asynchronous, so they always run in a background thread, and actor state is inaccessible externally by design, meaning you can't just reference the actor's properties and fields and do assertions on them. We have, by design, made that impossible for the most part. The reason being is that part of actor thread safety guarantees comes from the fact that actor state can only be accessed while the actor is processing a message. That's a pretty fundamental guarantee Akka.NET enforces in order to make concurrent programming safe and understandable. So the problem that this introduces is that it makes it difficult to assert pre and post conditions on actor state. Did the actor process this message, and did processing that message produce the effects that I expect? It also can lead to things like race conditions, where you can have tests that are racy. This is a problem that we are constantly combating on the Akka.NET framework itself, because we have in the ballpark of 7,000 or 8,000 different unit tests, and a bunch of them are built around non-deterministic test conditions, and those are where the race conditions creep in, and it's very difficult to track those down sometimes. So in an ideal scenario, what we want to try to do is design our actors to provide deterministic outcomes, meaning I have a black and white way of knowing, did this actor successfully process or unsuccessfully process this thing I asked it to do? How do I know if an operation is finished? How do I know if an operation completed successfully? Almost all the problems we have in the Akka.NET test suite are things that are being tested where we do not have an easy way of answering these questions. Therefore, we end up having to use tools like await assert and await condition, which we'll learn about when we introduce some of the TestKit methods in the next section. So for your applications, try to expose a deterministic way of sharing actor state and notifications when things occur inside your system. So I've come up with about 5 different, I think it's 5, ways of trying to create deterministic outcome, let's say notifications or designs for your tests. The first is the reply to sender pattern. Have the actor that is under test send a reply back to the actor who sent us the incoming message. They basically close the circuit with that actor by sending a notification once an operation is done. This is pretty easy and universal in a lot of actor-based designs. The next is a reply to address pattern. Bake an explicit reply to address in the messages that you're sending to the actors that are under test. This is really useful if you have multiple actors that are all involved in orchestrating something that needs to be tested, or if, let's say, the actor that's being tested has, let's say, a fairly complex state machine and you don't want to try to propagate the sender all the way through. Baking that actor directly into a message or into a state object or whatever, that's a good design that'll lend itself well to testability for those more complicated scenarios. Another pattern that I use very frequently inside our code is publish and subscribe. Have the actor that is under tests publish events when things happen to subscribers. So if I'm doing like CQRS or projections, I might actually have the actor that's responsible for publishing the events. I might have that actor use pub/sub to communicate with the actors that are doing projections. That means that I can also tie in my, let's say, actors that are my unit test actors, like the test probe that we're going to learn about in the test kit, I can have those actors also subscribe to those publish notifications and use that to go ahead and assert test behavior. So that's really useful. We also have a convenience method, the actor of as test actor f, which actually makes it possible to access actor state fields directly. So if you want to try to assert, let's say, a property that's built into your actor type, this will enable you to do that. We're going to see an example of that in just a moment. The other thing you can do is support query message types. Make it possible to just send a message to this actor and then get a reply back, so you can check the status of something after a operation completes. This last one is really useful if you have some non-determinism somewhere inside your application. Let's say, for instance, you have an actor that is polling an external API or maybe a database for changes. You don't necessarily have a deterministic way of knowing whether that actor has found the change it's looking for in your test, right? That's an example of non-determinism. Well, one thing you could do is you could implement pub/sub to make sure that you get a notification when the actor has found it. That'd be probably the most deterministic way of doing it. But the other way you could do it is you could go ahead and basically poll the actor who is itself polling using query message types. That's another technique you could use to try to make this as deterministic as possible. Pub/sub is better, but in the event that that won't work for whatever reason, query types work pretty well too. So these are some examples of how to add determinism to your tests. Let's take a look at some code where we're using a couple of these different techniques. So this is an example, and I'll actually pull up the full test class from here. This is an example from some of our demo applications tests where we're using the actor of as test actor ref. In fact, let me go ahead and just grab that. I'll close all these tabs. And I believe it's the subscription state actor specs right here. Yes, here we are. So what we're doing here in this particular test class is we're inheriting from the test kit. That is how you actually write tests that leverage Akka.NET infrastructure. You want to use the test kit. This will make sure you get access to the test actor, and it will create a brand new clean actor system for every single test you have inside this fixture. So you get a high degree of test isolation as well, which is really important. So scroll down here, talk a little bit more about what that does later. Here is the method that I had on that slide. I am going to take my subscription state actor, which is the type of actor I want to test, and I'm going to call this actor of as test actor ref method, and I'm going to pass in a generic argument for the type of actor that we're going to be testing, and then I'm going to pass in my props, my little formula for starting the actor. I'm going to pass that in as an argument, and I will get this type back, test actor ref of type subscription state actor. One of the things that you have the ability to do, in fact, I'll go ahead and change this so it's not implicitly typed anymore. Change this to subscription state down here. We're able to take our test actor ref and access the fields of the underlying actor. In this case, I'm going to access the actor state. I'm going to go ahead and grab the current copy of it right here. And I'm going to assert that the initial state should be in a status of not started. All right, makes sense. I'm then going to go ahead and use a query on this actor. I'm going to call subscription actor.ask. I'm going to pass in a query message right here, get subscription state. I'm going to use on the test kit the remaining or default. The Akka.NET test kit has a default timeout for all of its operations. It's 3 seconds usually, but that can be configured. And I'm going to say I use the remaining or the default, and I'm going to expect this response back. And then I'm going to assert at the end here that we should get basically a 404 whenever we try to query an uninitialized actor, because since no one has tried to create this description yet, they could have just, let's say, entered the wrong ID. The actor is always going to get started automatically by Akka.cluster sharding. But if it sees that it's been started and it's not been asked to actually create this entity yet, we're going to reply back with a not found. That's one of the ways we kind of make sure people can't accidentally spam entities inside the system. So this test is working as intended, and I could, if I go a little bit further down here, we're going to create a second test method where we actually try affecting the actor state, where it's not just going to be us querying the state and validating what the initial query state is. we're actually going to create the subscription and then cancel it and then resume it again. These are all different commands that will change the way the actor state is represented. So the first thing we're going to do is we're going to tell the subscription actor to create the subscription. We're going to expect a reply back from that actor, and that reply should be positive. And then lo and behold, I'm going to use the test actor ref subscription state actor down here to check the state and the product ID. The product ID would have been null prior to this. If it's now set to product ID 1, that means we successfully processed this command. So that's kind of yet another example of being able to, let's say, make a deterministic outcome here where we're inspecting the actor's state explicitly. But the thing that makes this work is actually this expect message call right here. It means that we're asynchronously telling this actor to process this message behind the scenes. Well, we're going to force our unit test to wait until we guarantee that message has been processed. And the way we guarantee that message has been processed is that the subscription state actor does the reply to sender pattern right here and right here, where we will explicitly send back a reply when we have finished fully processing this message, whatever the result may be. Closing the circuit this way allows the flow of execution of this unit test to basically have 100% determinism. I know that by the time this await operation completes, that this actor has processed this message. If this operation hasn't completed, and by the way, I technically don't even need to specify remaining or default right there. I think Copilot put that in there for me. But this operation will time out after 3 seconds if this actor has not sent the sender a reply back. And by default, the sender is a special actor called the test actor. The test actor is who we are asserting this expect message async on. We're basically asserting what message will appear at the front of this actor's mailbox within 3 seconds. If I leave the test actor off, this code will still work. So that's something that we'll learn about in just a second when we kind of start diving into the TestKit basics. But this sort of closing the circuit between the actor that's under test and our test itself is what allows us to make this test deterministic. So if I go ahead and I run this test, let me launch that real quick. And if I go ahead and do, let's say, run unit test until fail, this test is never going to fail. It has 100% determinism. Therefore, it will never be racy with the way it's currently designed. That is good. That is the ideal way we should ultimately try to deliver Akka.NET unit tests. It's not always feasible, and we'll see some workarounds for that when it's not, but this is the theoretical ideal.